Let me invite the second speaker today is Francesco Vaia, which will substitute Tobias Klein. Very short introduction of the speaker. Francesco is an electronic engineer. He started as a researcher at the CNR in Naples, and then he moved to the automotive sector as a system engineer. Then he moved to the Netcom. After an initial experience in Latin America, he moved again to Torino, and now he's a solution sales manager for the ETAS here in Turin. So thank you, and this is your microphone.
Thank you for the nice presentation. And I know that many of you are here because of Tobias, but unfortunately he's sick, so I will try to do my best to substitute him. So in ETAS, we are building all the blocks to secure the software-defined vehicle. And in this speech, we will try to explain the philosophy that is behind this, how we build this block. So we have 4 key messages. The vehicle computer that are the brains of the software-defined vehicle. The security that is a must for the new mobility. We will take a lesson for the enterprise IT security, and then we will try to explain the trade-off between the integration and the performance that we need to deliver in the software-defined vehicle. So from security perspective, the connectivity is one of the most important features for the new mobility. The new cars are constantly connected with our device, connected with the backend of the OEM, connected with the infrastructure like smart road or smart cities. So there is a huge ecosystem, software ecosystem that comes also from the third party. So the software is not totally controlled from the OEM and from his ecosystem, but there is also a lot of software that comes from other companies. For this reason, we talk about software-defined vehicle. That is a new experience of mobility where the experience is offered not by the car that you buy, but from the software that is installed in your car. This, in the software-defined vehicle, we have a high speed of software delivery because respect to the past, you could have new feature with the new model year that could appear in 2 years or in 16 months. But with the software-defined vehicle, you can have new features in your car in just few days. And this is also lead us to the continuous updates. So for this reason, the security is a must in the software-defined vehicle. We have a huge ecosystem, and also all the threats that can come from this connection with the infrastructure and with the software involved. So we can have password attacks, ransomware, malware, physical attacks. So all the endpoints and must be secured to deploy the software-defined vehicles. Now let's give a look to the evolution of the architecture of the new cars. We passed from a distributed architecture where we have all the main domain and the functionality that were encapsulated in one single hardware. And now we are migrating towards a vehicle centralized architecture where we have one or more brain that are domain independent. So how we deal with this to secure this new architecture? In the past, in the past architecture, it was conceptually easy because you had to provide the security functionality to one module, and then you could have the monitoring of this network. But now with these brains, the vehicle computers, we have an independent domain. So what is the philosophy behind? And for sure, we don't need to reinvent the wheel. We can take in account some lessons that come from the enterprise IT security. What happens in the enterprise IT security? We have several domains that need to be connected, like, for example, lab, software factory, or data center. And these domains need to be connected among us. So the solution is the cross-domain solution where you push all the flow of data in separated communication channels. And in these channels, all the data have to be unpacked, approved, filtered, scanned, and then can be delivered to the next domain. So in this way, you can secure the communication between different domains with different features. So we took in account this concept of cross-domain solution, and we created what we call automotive cross-domain security. So we applied this concept of automotive cross-domain security to the vehicle computers. To apply this concept, we also need another solution that is called hypervisor. Hypervisor is a high-level software solution that enables you to create virtual domains. With virtual domains, you can also separate flexible software positions that are separated in multiple domains. And from here, you can provide the security features. So basically, we consider the 4 virtual domains: the domain of security facilities for reaction and for detection, the domain of the virtual domain of safety features, and the domain of non-safety functionality that could be static on demand. And once that we have this virtual domain, we need to provide the security fundamental features, but also we need to care about performance of the software and domain vehicle. So let's talk about the prevention and the reaction. Once that we created with the hypervisor the virtual domains, we can configure local reaction to security threats. So we also can have targeted actions to these virtual domains. So let's make 2 simple examples. If we have a security threat in the safety domain, then we need to configure the reaction with a high alert state, because this is really a severe danger for the passengers. So we, for example, can shut down the engine, or we can close all the communication just to prevent any damage to the vehicle and to the passengers. From the other side, if we have a threat that we can find in the non-safety domain, we can manage in a really different way. So we can disable this new function, and then after with the new update coming from the recovery of the VSOC, we can enable with a new update of the software. So regarding the performance, this is really specific for the automotive sector, because in this side we need to care about the real-time application that comes from the safety domain. Here we have the need of low latency services, so our system to protect the safety domain that are collected in the hardware security module, like the message authentication or the key management or the cryptographic communication, need to be delivered to the safety domain in real time and with low latency. But at the same time, we have really different need coming from the non-safety domain. For example, for the domain of the infotainment, of the interiors. And here we have a high throughput of facility that we need to care. For this reason, we also need another solution that is called trusted execution environment. In the trusted execution environment, here we can provide security features coming from our hardware security model, but these features are limited. So for this reason, we need to have a trade-off between the needs of the safety domain and the need of non-safety domain. So we need a trade-off that needs to be designed from the beginning of a software-defined vehicle. So starting from this philosophy, in ETAS, we developed all the blocks that we need to secure the software-defined vehicle. So we have the hardware security model for the complex chipset like the system on chip. We have the intrusion detection system for host base that can interact with the hypervisor. We have the firewall, we have the trusted OS, we have the Ethernet switch, and we have all the blocks that we need also to cover for the smart sensor and the control units. So coming to conclusion, we talked about how it is complex to deal with the security of software-defined vehicle, because we understood that in the vehicle computers we need to care of safety domains and non-safety domains. We took the lesson from the enterprise IT security, where we understood that we need to create virtual domains that need to have local reaction that are really different. And this kind of performance need to be cared from the day one, because we cannot just deal with security for our certification for the ISO 21444. Last slide. So as Johannes said in the previous speech, all this activity that we have made for the software-defined vehicle, we didn't make alone, but with the partner of with several partnerships with the silicon vendors, with the tier one, with the car makers. We already experienced that some of the companies that tried to make everything alone, they already failed. So all the activity that I was talking today, they are already developing a project that with job one and the start of production in the early 2025. In ETAS, we are available for more than 20 security specialists. Some of them are here to listen. So if you need some further information, please visit us to our booth. Thank you for your attention.
Thank you, Francesco, for your presentation and for being in schedule. Is there any question from? Otherwise, I have one. So don't go away. So the software-defined network vehicles are introducing a much more sophisticated architecture, so you can introduce much more services. But what are the biggest cybersecurity threats against software-defined vehicles? And do you see any possibility that AI, with all the hype, with new technology, can really help also in mitigating them?
Well, as I mentioned during the speech, there is a lot of third-party software involved in the software-defined vehicle. The software-defined vehicle is also a new business model, where the car maker wants to sell the car, but also wants to sell the software. So we see that the major threat could come from this third-party software, like apps that can run in your car, and the vulnerabilities can come from there. So, for example, one application could introduce some vulnerability, or could be also some Trojan that could deliver some spyware. I think that all we know the news coming from the United States, when they, in the Congress, they wanted to disable TikTok for political involvements. Regarding the artificial intelligence, we are approaching them with machine learning to boost the performance of especially the analysis of the data that comes from the onboard and need to be analyzed for the vehicle security operations center. In this case, there should be also a second approach, because the first approach needs to be designed from the expert. But the second approach could be possible with the artificial intelligence that could analyze in a faster way and in a better way all the consistency of the data. Artificial intelligence could be also used for trying new pattern of cyber attacks, and so test our solution, just to understand if they are still reliable or we need to update it.
Okay, thank you very much.
Thank you.
And